Hey guys, welcome back to day 2 of doing one quant finance interview question every day. And today, our question is, if you put 10 balls into 3 bins at random, what is the probability that at least one of the bins will be empty? As per usual, I highly recommend you guys the possibility to think about this yourself, as it's really interesting. Hey, I hope you guys have a solution by now. If you don't worry, I'm going to explain the solution just in a minute, and it's going to be really easy and simple to understand. So kind of have the scenario drawn out down here. We have balls labeled through 1 through 10 and bins labeled 1 through 3. So for all the probability problems, so what I like to think about is how many events that satisfy our condition out of the number of total events. So in this case, the total events will just be how many different cases we can arrange 10 balls into 3 bins. And we know for each ball we have 3 options. And if you have 10 balls, so all these cases will just multiply by each other. So for 10 balls, the total number of cases will just end up being 3 times 3 times 3 times 3 times. You got to do that 10 times, which will give you 3 to the 10. Now we have determined the total number of cases we have. We just want to find out of these 3 to the 10 cases, how many satisfy our condition of having at least one of them empty. So intuitively, we know we can classify these cases into 2 different categories. The first one would be just having exactly one bin empty. And the second one would be having 2 bins empty. The first scenario is more general, so we're going to start with this. So in this first scenario, we can think about it this way. If you want to have one bin empty, this means each of the balls will only have 2 options. So instead of the 3 we've been multiplying here, we just do 2 multiply. And the calculation is the same. Each ball has 2 different options, so this will just multiply by each other, and that will give us 2 to the 10 different cases. But remember, these 2 to the 10 cases are only the possibility for having one specific bin empty. And how many ways can you choose a bin to be empty? The answer is 3, because you have 3 different bins. So the total number of cases of having one bin exactly to be empty would just be 3 multiplied by 2 to the 10. And that's our total number of cases having exactly one bin to be empty. And then let's think about having 2 bins empty, which means all 10 balls would just be put into one single bin. And intuitively, we know there's only 3 cases for that. You know, either all of them getting put into 1, or all of them getting put into 2, or all of them getting put into 3. So the total number of cases we have will just be 3. And now, after finding these 2 numbers, which represents the the number of having exactly one bin to be empty and the number representing having exactly 2 bins to be empty, we got to be really careful, because having 2 bins empty are technically also satisfying the condition of having one bin empty. So when we're doing the calculations for having one bin empty, we kind of double counted for the scenario of having 2 bins empty. So what we need to do is to subtract the 3 from the final number of cases. And this will be the number of cases that actually satisfy our condition. And the probability will just be that over the total number of cases, as we said before, would be 3 to the 10. Evaluating this would give us 341 over 6561, which is approximately 5.197%. And that's our final answer to this problem.
Hey guys, I created this sandbox simulation for the problem we were just doing. So here we have already done 1900 trials, and the number of bins that at least one of them will be empty, the scenarios where at least one bin will be empty is 100, which gives us a simulated probability of 0.0526, and probably we just calculated it was 0.0520. So we just, if we let it run for a longer period of time, you can see the number kind of slowly converging to our theoretical probability. And if we pause the simulation, we can actually see out of these last 30 trials, only one of them satisfy our condition, having, this for this time just the middle bit that's empty. So it's pretty cool. They can kind of like visualize this problem.